Now, this is the type of question you'll need to answer on the final exam. A box is fastened to a string that is wrapped around a pulley. The pulley has a radius of 4 meters. The pulley turns through an angle of 43 degrees, during which it is dropping the box. So how far does the box drop as the wheel turns by 43 degrees? So with your clicker, tell me what you get. Work it out with your neighbor and then use your clicker. Okay, if you haven't voted, get your clicker points. Okay, we're kind of all over the map here. And that's okay, because this is a challenging problem. And I set you up. I made it more challenging than it had to be. Let's solve it together. First off, we need to recognize that in order for that box to drop 1 inch, I have to let out 1 inch of line. Anyone that's been fishing knows that. And so that means as this wheel turns through 43 degrees, that arc length is going to be the distance we're looking for, the distance that the box drops. Now that arc length would be oh so simple to calculate if I had given you the angle in radians. But I purposely gave it to you in degrees to show you how complicated this can be if you're using the wrong units. If I had told you that 43 degrees is the same, exactly the same as 0.75 radians, now it's going to be simple to solve. I'm looking for the arc length, and that arc length is part of the definition of the angle. So instead of S as the arc length, I would replace it as the distance D that the box drops. And then I solve for D. Well, D is just the radius of the wheel times the angle in radians. Well, that's going to be 4 meters times 0.75 radians, and that's going to give me 3 meter radians. That means that the box drops 3 meter radians. Now, does that sound funny to you? I would like to say the box drops 3 meters, because a distance should be measured in meters. So why don't we just drop the radian? If we don't like something in physics, can we just erase it? It's the way some of us have been operating. It turns out that in this case, it's okay. Because if I look at the definition of the radian, it's an arc length divided by a radius, which is a length. So the units here, radians, have to be the same as the units on the right-hand side of the equal sign. That's going to be meters for the arc length divided by meters for the radial distance. And that cancels out. So the radian doesn't have any actual units. It's a placeholder to remind us that we're talking about an angle. And so whenever it's inconvenient, we can just get rid of it. Or whenever we need it, we can just insert it. It's just a placeholder.